Hello, folks. Welcome back to another demo day. I'm Hubert, and today's demo will be getting data from Kafka into S3. Today's data we're going to be working with is crypto data, cryptocurrency, specifically price tickers, and we're just going to send them straight to S3. This shouldn't be a very long um, demo, but it will be a bit detailed because I'm part of this demo is I'm going to install Apache Kafka from scratch, and there are some things you need to configure. But basically, what we're trying to do is build this, and it's really super easy. In fact, I had to add the parts to build and install Apache Kafka because the parts in Decodable are just that easy to take up some time. So, and plus, uh, there are some things if you want to get started with this, there are things you need to check out and configure before you start configuring and using Apache Kafka when you deploy it in the EC2 instance. So that's what I'll try to cover so that you can actually build this yourself with all the information you need to be able to get it all connected together. Okay. Just escape from here if I can. Just minimize this. Great. This, again, if you guys are interested in any of the demos that we show in demo days, we try to add all those demos in our examples repository. You can see we have a lot of other previous demos. You can always go in here and build them yourself. And if you have any issues with them, reach out to us and we'll help you out. But a lot of these are super easy to build up. And I think I'm missing one from last week. So I'll make sure to add that in here. But in here we have, I think last week was Tinybird, so I'll add that to the front page. But today we're going to do Kafka to S3. And click in here. I was going to do multiple Kafka types. Our first type is going to be Apache Kafka. Next time we might do MSK or some other version of Kafka out there. There's plenty of other fully managed Apache Kafka services in the cloud. But this is for self-managed, so you'll have to, the way we're going to do it here, at least, is the start up an EC2 instance. I have my, they call this the console to AWS here. And so we'll reference this whenever we need to. Okay, so let's get started. This is my EC2 instance. I go to EC2 here, make sure I'm in the right region. And I already have an instance running right here, okay? And in fact, I've already SSH'd into that instance. And I've already conveniently have done all the kind of annoying, preparations, installing the components that we need to be able to do the parts that we need, especially like Java, to be able to run Apache Kafka, and some of these other tools will help us to visualize some of the information that we're looking at, especially specifically with this JQ. We're going to use that to read JSON outputs in case we need to read JSON in a like clear text. Okay. So notice I have nothing in my directory. So first thing I'm going to do is just copy this command to download Apache Kafka to my local EC2 instance. We'll CD into that, and then the first thing we need to do is configure a configuration file for Apache Kafka. Okay, so let's untar that. And there we are. Let's go in that directory. And here we are. This is the home directory for Apache Kafka. So we want to look at, we want to edit this file here. Well, let's take a look at inside that configuration directory, because I think it's very helpful to understand. There are a bunch of configurations. They're all Java property files. The ones that we're going to be using are the Zookeeper. The version of Apache Kafka we're going to use still uses Zookeeper. You can configure it to just use the brokers with KIP 500. You could have a Zookeeper-less brokers, but we're going to just use the Zookeeper as it's good for getting started with Apache Kafka. The next thing we're going to actually edit is the server properties. This is what we give to the Kafka broker, okay? We're going to start a single node Kafka cluster. Since we only have one EC2 instance, you could create more EC2 instances and give them the same server properties. You'll need to change a couple of fields in there to help them communicate and find each other so that they start to communicate with one another. Okay, we're just going to start one broker, one node Kafka cluster. Some of the other properties in here for Kafka Connect. Here's some logging configurations. We're not going to really bother with these because we don't need not even like any of them really, except for those two that I mentioned, because Decodable handles all the other parts that that you need to be able to build this flow from Kafka to S3. Okay, so it makes your streaming platform, in this case Apache Kafka, really simple, lightweight, and as a side effect, really fast. Okay, let's start. Well, let's configure our broker first. So we're going to use VI to configure this this configuration for the broker. There's a lot of information in here. A lot of it has to do with where your data goes when Kafka is receiving it. So that's your data directory. Lots. We're not going to cover all of these. We're just going to cover a couple of properties. And those are the ones at the top here, the listeners. One interesting one is the broker ID. So if you were to create another broker to create a 2 or a 3 broker Kafka cluster, you would assign them a unique ID. So this is ID 0. You create another one, I would assign it as ID 1, 2, etc. Okay. But first, we want to uncomment this. This is an internal listener. This is how Kafka will communicate with itself or other brokers. So we want to set that as like a local host or that IP. And the advertised listener, this is an important one. This is how you actually get remote clients like producers and consumers talking to Kafka, this instance of Kafka. If you don't set this properly, or if it doesn't work, you will not be able to use your Kafka remotely. You'll be able to communicate it locally, but not remotely. So we need the public IP for this EC2 instance. So let's grab that. Here it is in AWS. Let's just grab that and put that in here. That's right now. Okay, that's it. Okay, let's save that. And now let's start both Zookeeper and Kafka, or the broker. We use Zookeeper here. It's the way that Kafka does consensus. So it is a distributed system because each broker can live on a separate instance. Normally you would deploy this on Kubernetes, but since we're doing everything here by hand, it's good to understand how all this kind of works. So we're going to start Zookeeper. Um, so as I said, Zookeeper does the consensus. It does the voting between the nodes. So it's not really doing anything since there's only one node running. So it's just there, but Kafka still needs it. So we're going to run it. This flag here tells it to run it in the background. If you don't give it that flag or that argument or that option, everything will run in the foreground, and you won't be able to use the prompt. So let's let that run in the background. And let's run the Kafka broker. We're also going to run this in the background, and we'll accept the changes we made in the server properties. Okay. Let's let that run for a second. They should, what you could do is tail the logs in the log directory. There's a few logs in here, one for Zookeeper and one for Kafka, server.log. As you can see, it started already, and as it starts to do stuff, you could follow this to debug your broker. Okay, let's cancel that. You can also check to see if your two instances are running in the background. So you can just grep for Java, and you'll see that here's the first one, which is Kafka. Right. You can also see it down here that it's using Kafka. And the one before that is Zookeeper. You're passing the Zookeeper properties, and there's Java up there. Okay. So they're both running. So let's test it out. So what we could do, I have some tools in here you could use, and I hope I put them all in the command or this thing. There we go. So I'm using Kafka Cat, or it's now called KCat. What you want to do is go to any machine. So I'm going to use my local machine, have it communicate to this remote EC2 instance that has my Apache Kafka running. Okay, I'm going to use this as the command. I don't think my bootstrap variable is set, so I'm just going to run it here. My bootstrap server is going to be now my EC2 instance, right, on port 9092. And this command here is list all the topics. It's going to be empty, obviously. Oh, so let's check to see if this is how I check to see if it's up and running or if it's accessible. And it's not. This usually comes right back. So what can we do to figure out what this is doing? If you go to security and you look at your security group, so these are the rules or security rules that your EC2 instance will follow. So if you click that, notice that the only open, well, if you look at the inbound rules, the only port that's I'm allowed to use is really the SSH port. So I need to add a rule here to allow Apache Kafka to talk to anybody. Let's save those rules. Let's go back to my EC2 instance. Here it is. And let's try our netcat command again. So it succeeded. And let's try our Kafka cat list topics. So we have one broker. Again, we knew that. We have 0 topics. And this is a controller. It knows the controller. Controller kind of is like the boss of all the other brokers, if you want to, for a lack of a better term. Let's create a a topic. So we could go kcat dash h. I don't know that you can create topics with this one. So I'm just going to use the command lines in Apache Kafka. So I just listed the contents of the bin directory inside my Apache home. And notice there's tons of tools, command line tools in here. What I want to use is the one that says bin Kafka and something to do with topics, right? And let's look at the help for that. Should be a dash help. Wait. And I want to use, I want to create. And then I think this default stuff, I don't need to give it the bootstrap server, the defaults to local. So I'm just going to use create. Create, and the topic I want is crypto. Let's see, bootstrap server is required, so local host colon 9090 bootstrap servers. Bootstrap. I think I need to put HTTP in it. Bootstrap server. Oh, I spelled it wrong. Bootstrap. Take that out. What did it complain about? 9092 create. Required argument topic. I think I need to put this at the end. Crypto. Oh. Missing topic. Oh, topic name is going to be crypto. I need to get that flag. Oh, that took a lot longer than I thought. So going back to my command here, I want to list all my topics. Now I have one topic called crypto, and now we're all set. I got my remote client, which is my computer, talking to Apache Kafka on the back end. So let's create a connection to my Kafka that I just created. We know our broker. Let's get that from our command line, which is this one. Paste that in. Our topic is crypto. That's it. Next. I want to create a new stream, and I happen to have the this information already written out somewhere because I don't want to do it again. It's up. So I'm just going to create a fake one because I already have this all running in the background. So let's create a new stream. Let's call it crypto raw. Demo. They already have one running in the background. And then we can add our fields in here. For instance, I think if you know your format of your data, so there's a sample right here. And what you would do is go to each one. This is a string. Maybe I'm Now let's do that for each one of a currency. Let's see. And so on. I'm just gonna leave that. And this is a crypto Kafka source demo day, right? So it was able to create, it verified the endpoint or my broker exists. A lot of validation actually happens when you get to this point, so you don't actually have to do much to verify that this has been connected. Okay, so now we've created, installed the Apache Kafka, configured it to speak to remote connections. We were able to create a topic and connect a decodable to that instance. Okay. And I didn't start it because I actually already had this running. And it's called this one. Okay, so I already have this running on a different EC2 instance. Okay, and we're going to kind of navigate through this pipelines. We have this way of navigating, like this kind of like your forward and back browser buttons, but they, in this case, are for your different steps in your pipeline. So if we go forward, this is the stream that is connected to. So everything that's coming in through that Kafka source connector is dumping into here. Okay, you can look at our data. That's why I didn't want to build that schema. It's way too big for the time that we have. And there's some complexity in here. So if you look at the schema, you'll see that this is how we handle our complex types, right? So we have two complex types in that JSON. And for a complex type, you want to use a data type called row, and within the angled brackets here, define the fields in that complex type. Okay, so if you have multi-level objects, you can define another field in here called like foo, and then have that yet be another row type, and then add that to your schema here, like bar, and have that be a string, right? So that's a multi-level schema. So you can you can keep doing that, infinitely. But let's cancel that. We don't want to change that. So that's what's happening here. We've defined some types. The schema is very, loose. For instance, this price probably is in a string. This date probably is in a string, but it all came in as strings. If you notice the sample data, everything is in quotes. So we have to clean that up. We're not going to clean it up too much because that's, again, a lot of work. So let's check that out. This is I have two pipelines reading from this. A pipeline is, in decodable terms, basically SQL. We look at the data. We're looking at the stream where all that data is going to, crypto raw. And we start to parse that data. Let's actually go back one and look at a more sophisticated one called crypto raw table. Actually, it's not that sophisticated, in fact. But this is, let's not show that one. That's kind of annoying. Let's go back a couple. Let's go back to the one we were looking at. So here, so I'm not, again, not doing too much with this, but I am transforming this field into a price, to like a formatted timestamp, right? So this is a string. This is a string. This is going to parse that string and convert it into a timestamp, and you get this date here. Unfortunately, the data that I've been getting has that field empty for some reason. Not sure why. So it's null. And This only happened recently, so I'll have to go back to this and kind of figure out what's going on with that date. But we could take this data and put it into a sink. So if we look at if you go back here, this is the original connection connected to Kafka. Click to the right. This is the stream that is writing data to. Click to the right again. We go to the pipeline or the SQL that's transforming this data. This is the transformation engine. Click right again. This is the output of that pipeline. And if you click lastly, this is where it's taking that data and writing it into S3. Okay. One thing that we want to do quickly is to figure out, to understand how to configure an S3 is probably the hardest part in building this pipeline. Only because you want to be a bit secure. This is connecting to AWS, so let's try to build an S3 sync connector really quickly. So I have one. This is my bucket. Whoops, that's not my bucket. This is S3. Here's my bucket, Hubert demos. Notice that it's going into crypto directory. This is my data coming in. But I want to create permissions to be able to write to that bucket. And the way we do that is through here. So as you want to say US West 2, my bucket is Hubert demo. My directory is crypto. And this is where we need to figure out what to put in here. What we require is for you to go to your IAM section in your AWS console. You want to create a role. Notice I've already created one previously, but let's create a new one. Click here, the custom trust policy. And in here, you want to grab from our, let's move this stuff around here. Our documentation. In Decodable, just grab this guy right here. The trust policy. Trust policy. Paste that. You want to replace this value with Decodable demo, which corresponds to this thing up here. Drop down that, and you want to grab that value in there. That's your account name. Okay, you want to put that in here. Okay, this also refers to Decodable through like the principal and so on. I don't want to get into that. So next, you want to assign it a policy. So these are all different permissions that you're allowed to add, to apply. I've created one in here before, MSK. So let's create a new one, just so we're full. We're covering everything. Click on the JSON and go back to our documentation, and you just want to copy this one. Go back to that tab, Control-Alt-V. Okay. So this provides all the permissions that I'm allowed to use. And this is the resource that is allowed to we're allowed to use it on. So this is really all I want here is Hubert. It's a demo, can't remember now. Demos. So demos, that's the bucket. Just type that same information here. And that's it. Click next. You could skip that if you need to, or would like, and then you give it a name, Hubert demo day. Create policy. Okay, so find yourself that you find that policy you just created, demo day, and grab your ARN. It just shows up right here. Oops, you want to grab role. I'm sorry, I went to the wrong one. Where's my role that I just created? I need a refresh. All right, so not sure what happened to AWS there. It was a glitch, but your role is going to live right here, your ARN. So you copy that guy, and that's what you put into your ARN, right? You could populate this if you'd like. You could give it a timestamp of some kind and start to partition your date. Give it some subdirectories underneath your crypto directory. That's what I was trying to do with my your S3 buckets here, but I'm getting a bunch of null timestamps. So when I start to get some, or I find out why I'm getting null timestamps, I'll figure that out. You'll see some subdirectories in here with the year, day, date, and so on. Okay. So that's what that field is, be able to partition your data on any field inside the data, or a date field, so on. Okay, and this is a format of your data, and timestamp next. You actually just grab my demo day raw. So I want to grab that guy. So it already infers the schema based on the stream you would like it to use. Click next, give it a name, crypto S3 demo. I think it's oh, I'm already using it, so I can't use it. I'll have to change that directory. Let's give it another directory name. May have to create that directory name, directory. Yeah, I think I have to create that directory. A folder. Go to create folder. So it takes a second for it to realize that there is a directory in there. Bucket does not exist. Demos. There's stuff is hard to remember. So there's your your connection, and you just start it, and you start writing into S3. As you saw, I'm already writing demo or data inside S3. This is that crypto data. To look at it, you can click on one, and you could open it in another tab. Here's that data that's coming through. Okay, that's how you view data, and you can also download it locally if it's a really big file. The interesting way that's special about this S3 sync connection is that it groups or batches data together. So it doesn't have one record per file. What that causes is what they call a small files issue, which if you do have increases the amount of metadata you have to handle. So if you were doing any, say, like reading Spark or using some kind of like Python job to read all this data, it has to send a bunch of API requests for every file in your S3 bucket. So what will happen is that you'll see that you'll get charged for every one of those API calls. So the more files you have, the higher your monthly cost will be to AWS. So this is why we batch everything together in bigger files so that you don't run into those kind of situations. If you were to do this yourself and like say wrote a Spark job reading from Apache Kafka, you also have to do the same thing if you're going to write it into, say, a Delta Lake or a S3 bucket or some kind of a data lake, right? You have to find some way to make sure that you're not creating a bunch of small files, because you'll either get charged a lot by AWS, or if you're self-managing your data lake, you're probably going to run out of memory in the metadata server. So best practices, what Decodable kind of follows, make sure that you don't get to that point where you have a lot of small files, right? It's a very opinionated approach. When you were building pipelines in Decodable, we want to get you to a point where you can use it immediately without incurring downstream issues because of issues that you didn't really know about, like small files, right? We've already thought about all those ahead of time so that you don't run into those issues later, okay? This completes our demo. I hope you learned a lot. There was a lot of information in installing and creating an Apache Kafka server, connecting to it remotely. Notice that the parts that involved Decodable only really took us about 10 to 15 minutes to talk about, while installing Apache Kafka really took about the other half of that of our meeting or webinar today. Any questions? If not, it was a pleasure showing this to you. Reach out to us if you would like to have any help on configuring this same use case, and we're join our community demo Decodable channel, and we're always keeping an eye on that for any questions and problems that people are having. We're always willing to help. Thanks a lot, and see you next time.